When two forces act on an object, the resultant force can be represented by the sum of the two vectors, and that's fairly intuitive. When one force pushes this way, one force pushes this way, the object gets pushed this way, with an amount of force would be equal to the sum of these two forces. See, that's how we can use direction together with this thing. So, here's an example problem. Two tugboats, perfect example, are pushing a barge, each with a force of 500 pounds and each making a 30-degree angle with a line through the middle of the ship. What is the resultant force on the ocean liner that these two, barge, catch things now and then. What's the resultant force on the barge? Okay, there we go. They're pushing a barge, and of course they both have to use the same amount of force, otherwise this barge is going to be driven around in circles, and that's not very helpful and wastes energy. So they're both pushing with a force of 500 pounds. Each is making a 30-degree angle with a line through the middle of the ship. What's the resultant force on the barge? Well, this is 500 and this is 500. See, this 500-pound force, I can represent it with this vector. This 500-pound force, I can represent it with this vector because I can move them wherever I want to. But I don't know if you see the beauty of this. This is a 30-degree angle. This is a 30-degree angle. So this is a 60-degree angle, and so is this. So we got 120 from these two. The total for a quadrilateral would be 360. So these two, which are the same, have to add the 240, so each of these is 120. This is a 120-degree angle right here. And I got two sides in the included angle. Pause. What can I use to solve a side angle side non-right triangle? Resuming from that pause, you've come back with the knowledge that I would use the law of cosines, of course. And so here's the law of cosines applied to that particular problem. The side x squared, I called it x instead of f1 plus f2 just because I didn't want to type all that. So it would be 500 squared plus 500 squared minus 2 times 500 times 500 times the cosine of, now I would have put 120 degrees in there because that's what this angle is, but my software doesn't really like degrees. I'd have to convert by multiplying it by pi over 180, so I just said, alright, let's just call it 2 pi over 3. And that's what I did. And then instead of doing all this arithmetic, which you guys are, and anyone, any human, would do this with a calculator, I just went ahead and typed it in, said simplify, and got x squared equal to 750,000. So therefore x is the square root of 750,000. I started simplifying that. 10,000, square root of 10,000 is 100, so 100 times square root of 75. The square root of 75 is 5 times square root of 3, so that 5 times that 100 gives us 500 square roots of 3. That's the resultant force from these two boats pushing on that, and then I did a decimal approximation of it at 8.66 pounds, I guess that would be. Okay, probably good reason why the tugboats can't push at the back of the barge. Maybe there's rudder there and stuff like that that they wouldn't want to damage. So, cool problem. Hope you found it useful.